Hello, I'm Eric Snodgrass, and thank you for watching this Ag Forecast brought to you by Nutrien Ag Solutions. Well, here we are in the middle of the afternoon, and I was waiting to see convective initiation in parts of Iowa, Minnesota, and Wisconsin. And so that's what I'm going to talk about first. So this is a satellite loop here. We're just kind of going back in time throughout the day today to where the sun rose, so right into there. Now you can see a few things as I kind of animate back and forth. There is a broader area of higher pressure sitting over the four corner states, and that's been the source of not only the heat with this system, but also with the wildfire smoke that we've seen spread throughout this area. But then throughout the day today, we had the storms. Let me take you back there. There were the storms early this morning, cutting through some of the driest parts of the Midwest, putting down, in some locations, decent precip, but this was a lot of hit or miss. I'll show you in a few moments the total precip. And then as we work throughout the day, the next boundary, which is stretched right in through here, we were going to watch that to see convective initiation, when the new storms were going to pop. And the models have had a difficult time figuring out when these were going to go and where they were going to go. And now that we've seen them go, we need to discuss where they're going, all right? That's been the setup right in through here. Now first, how much precip did we get over the last 24 hours or so? And in general, some of these very dry fields in this area, some folks were quite lucky and got some heavier rains, but most of this very dry region missed out on this. And outside of that, that was really the only region around the country that really saw wider coverage of precipitation. Now, of course, a lot is coming in with the northern edge of this tropical system, which you saw in the previous animation as well. And we're going to talk about that in a few moments. But what I'd like to get to next is our all hazards weather map. We still have a very broad area out here of heat advisories. Now down here, all of these colors you see here, these are air quality alerts, and they go up into parts of the high plains as well. We had red flag warnings out and excessive heat, and we'll talk about that heat in just a few moments here. But a lot of this is caused by the smoke, and we've got flood watches already posted for when the tropical system does eventually come in here tomorrow. But next thing I want to look at here is what those temperatures are right now. So this was kind of a look at 3:30 when I was doing this recording this afternoon, and we can see that we were well into the hundreds across a broad sector here of the midsection of the United States, and much hotter down here in the desert southwest. So very, very hot day extending into Iowa. But the frontal boundary right in through here is what we're going to be watching for the initiation of some of these storms. Now, the Storm Prediction Center had been upgrading all day the area of enhanced risk. So if you're unfamiliar with this, it's kind of like the fourth level out of 6 in terms of severe thunderstorm risk area. And what I want to do is I want to take you kind of to a live shot at what's going on in this particular area right now. So let's go over and take a look at some radar. So what we're watching here, I've used the Des Moines radar to kind of show us what these storms have been doing today. And a point to make here is that the majority of these storms were not forecast to initiate until much later on in the afternoon than they currently are forecast at this point. And as we watch them move across this area, they're moving into some very hot and unfortunately some very dry air that's in this particular region, and you can kind of see them, fading a little bit as they go through this area. But as this whole boundary, we just kind of look at it, kind of stepped out here. In fact, let's go over here and take a look at the radar here in Wisconsin. We're going to watch later for these storms to potentially produce their own outflow that then races across this part of Wisconsin this afternoon or this evening and possibly move in here to parts of northern Illinois. So this is kind of the nowcasting we're going to go through with these thunderstorms. Again, the models did not tease out very well where they would be. So why don't we get back into this and take a look at what the current observations are. So these are the latest data we have available to us. These are all the surface weather stations we have scattered here throughout this part of the Midwest and plains. And you can see the one thunderstorm symbol on there, but look at the area ahead of it. The temperature's deep into the 90s. This one's 96 with a dew point of 64. And so this air here, to be honest, to really get this to just explode with convection, we would need to be able to see these dew point temperatures maybe another 5 degrees higher than that. And I would just like to take a moment in this extended video to kind of explain to you why. So there was a special sounding. This is a weather balloon that was launched today right here in Davenport, and these are the data. And what we see here is this low levels of the atmosphere in here are relatively dry. Now, how I can tell that is by looking at the separation between the dew point temperature line and the air temperature line. Now this was put up at 18Z, so 1 o'clock. And in the afternoon, the temperatures would have almost had to get up here to almost 100 degrees Fahrenheit. In fact, the convective temperature was 104 degrees Fahrenheit before the atmosphere automatically overturned. And so as we look at this closely, what we're going to have to figure out is, as we move toward this environment here on the border between Davenport, so border between Iowa, Illinois, and Wisconsin, the question is, can we tap into this cape? This is what we're watching for right in through here. This is the convective part of the atmosphere. This is where it's unstable, and that's where the potential exists. And a couple of things to take note of here. If the storms do get over this cap, which is right here, and then eventually start to kind of pop into the afternoon, what is a case here is that we do have quite a bit of dry air, and that tends to lead to very strong downdrafts. And if we look, our D-Cape values right here, they're over 1,500 joules per kilogram. Generally speaking, when you're over 1,000, we need to be watching. So the point to be made here is that these thunderstorms going through do have the potential for producing very strong downdrafts, which then produce strong outflow and locally damaging winds. And so we'll have to be watching for those wind reports to be coming in here. The Storm Prediction Center graphic, again, the primary risk in this area is going to be from damaging winds and large hail. There could be isolated tornadoes, but the damaging wind and large hail are the primary risks. So I would like to make a point here, because I know I got asked several questions this morning. Is this going to be another derecho event? That certainly is something that's on the mind of a lot of us in the Midwest, especially those in Iowa. And I'd like to explain to you maybe some of the differences between what we've got now and what happened during that derecho. So this was back on August 10th, 2020, and we had over almost 1,000 reports, over 900 reports of severe winds, and that's all the blue dots you see in here. Now, on this particular day, Davenport launched a special sounding just before noon, and I have it for you here. Now, a couple of things to point out that are different. The low levels of the atmosphere were much more humid, a lot juicier, and we didn't have the big cap to which needed to be overcome to make this into a nasty storm. And that's why we were able to build in so much instability here. That's the area between what we call the parcel line and the environmental temperature line, right in through there. Sorry, I'm having a difficult tracing it today. What I think was more key was this wind profile. All right, we call this unidirectional shear. All the winds are essentially going the same direction up through the mid-levels, even the upper levels of the atmosphere, but they're increasing in speed. What this allows to have happen is that the storm then can produce its own outflow, which serves as its own trigger for new storm cells out ahead of it. And it's kind of like, with a storm like this, it's kind of like riding a wheelie on a bicycle. It takes balance where the outflow of the storm must be matched with the speed, the forward speed of the storm, to keep balanced so that it feeds itself. Sometimes what these storms will do, though, is that, you've ever fallen off your bike trying to do a wheelie, the bottom kicks out from underneath you. That's what happens when some of these storms kind of gust themselves out. And this particular profile, which we've been looking at here, didn't do that. Now, the question is, let's go back. Here we go. Let's go back to this one. Now you start to see some of the differences. We do have much more disorganized wind field here. Now, it could start to look better as this evening wears on, as we get over to this part of the state. But we call this a hodograph. And to be honest, this is not the style hodograph you would expect to see to have a very large damaging squall line. Now, my point behind telling you all of this is that some of these storms may locally produce some nasty conditions. And if we come back again to the area of risk this afternoon and this evening, we'll watch this area very carefully. But we'll have to do nowcasting through it. Watch the radar to see when the storms are going to get to you. That's my main story here. So from there, let's then go here. Let's take a look at what the high-res NAM model suggested. You see, those storms were already going at 4 o'clock this afternoon in this area. All right. Yet the models, neither this one nor the high-resolution rapid refresh, had initialized them. The models were much later, by this evening, initializing the storms in this area. And that means that what you're about to see here through the afternoon and evening hours and into the overnight is probably not correct. It's going to take much less time for the storms to do what you see here. Now that means that everything beyond this is also going to be a struggle to forecast. What we do know is that throughout the day tomorrow, there will be a boundary that sits in here, a frontal boundary that sits right in through this area. And And what the models had suggested, that was by tomorrow afternoon and evening, we could see along that boundary an area where we have some nasty storms. The Storm Prediction Center has identified this entire area tomorrow. And the Storm Prediction Center this morning used some pretty strong wording about the risk from central Indiana to central Ohio for wind damage from some of these storms. While they did not use the term derecho, that's a very special term we use to define kind of our biggest and baddest squall lines. The chance for damaging wind in this area is elevated tomorrow. And you can see that it could possibly be a late afternoon into the overnight hour type event, and it could also be multiple rounds. Do you see that? I'm kind of going back and forth. This is 5 p.m. all the way until the early morning hours. And I would just say that you would want to watch this entire area for the risk as we get into tomorrow. So keep a very close eye on the radar. There will be some damage, and I understand where particularly this corn crop is. It's very vulnerable to green stap at this point. So this will be an area we're going to watch very carefully as we go through. Now after that, the show then shifts south, and as you can see, now this is the high-res NAM, not the best model to track tropical systems. Well, we could have a pretty decent tropical depression that moves through parts of Louisiana, Mississippi, Alabama, and then throughout the weekend kind of combines up with that front on Saturday night and pushes over toward the southeast here toward the mid-Atlantic. So to see that, this was the latest update from the National Hurricane Center. They have yet to bump this up to a tropical depression. They've still got it at a 90% chance of development here, as you can see. And if we just kind of look at the overall steering current with this is about a mile above our heads. That's what the winds are doing coming out of the Caribbean. Here is the deeper low that's going through Canada and the front on which those storms are coming. So these things are all going to combine to take this system on a pretty hard turn in this direction once it comes onshore. But it does have the potential for dropping quite a bit of rainfall. Now we're actually going to look at 3 different forecasts of rainfall in this video. We're going to compare the WPC. So this is from the National Weather Service. They combine weather forecast models plus their forecasters providing human input to produce this particular map. And then we're also going to look at the GFS and the European. So as you look here, this is showing us total accumulated precipitation through the next 7 days. And there's a lot that we're getting updated here for my video on Monday. First of all, we now have a better idea on where the heaviest corridor of that rain is going to be. And in this area, there's the potential for 4 to 8 inches of rainfall in some places. And it still extends well into 2 inches as we go over the Appalachian Mountains. Now in this particular area, we not only have our chances of storms today and tomorrow, so Thursday night into Friday, but then there is a low pressure system that's going to try to come in like this, I'll show you in a few moments, that gives us another chance at getting some rain in this area. Now remember, when you look at this, it looks as though a lot of people are going to be getting at least a half of an inch of rain, but it's important to remember that thunderstorms don't deliver rain in nice smooth maps like this. And that area is very dry. Through the beginning of June, there are some places in western Illinois, southern Wisconsin, Minnesota, Iowa, Nebraska, South Dakota. Come right down here from South Dakota, Nebraska to Kansas that are exceptionally dry, some of the driest on record. And over the last 2 weeks, there are places in here getting back into Kansas as well where we've not measured rainfall. And it's been extremely wet where that tropical system is going to go over. So it means we have a major flooding threat to the south. And this is going to be an area that we're going to watch for some recovery over the coming days. Now, we can't get full recovery from just one event. We need to see this multiple times again and again and again, maybe 2 systems a week for like the next 45 days to completely revive this area of its drought concerns. And the reality of that happening is pretty slim given the stuff I'll talk to you about at the end of this forecast video. And so this is going to temporarily kind of, I think, buy us a little time, helping the crop out where the rain does come down. I just hope that the severe limits of this are minimal. So let's now get into all of that. As we've been doing, we're going to do our multi-model comparison. GFS is on the left and the ECMWF is on the right. And we did wait till both of these models came in with 12Z runs to show you this. All right, as we go through, this is now getting into this tonight. So you can still see that the models are late on bringing that in, but both of them do bring in those strong storms into southern Wisconsin and northern Illinois. This is Friday morning. Friday afternoon, and Friday evening. Now, remember, these global models will not be able to properly resolve the risk of severe storms in this area. But you do see that once you get into the late evening and overnight hours, that they are attempting to blow up those storms in that area. There's better agreement now on where the tropical moisture is coming to from from both of these models. So let's play this forward, now getting into Saturday afternoon and evening, then working our way here into Sunday morning, afternoon, and evening. Now this is what I'm going to be watching carefully. You can see that there's a broad area of lower pressure here in the GFS, and it also exists right in through here in the European. And this came out of British Columbia. Now, as we move forward, this is getting into Sunday evening. The chances of this bringing another round of rain through the very dry fields in Minnesota, Wisconsin, Iowa, getting down into Missouri, Kansas, it does show up. I know that the European, when you look at it, doesn't seem to extend it farther to the south, and that's important to know the difference. But as we then play forward, this is in the overnight hours on Sunday, getting into Monday morning, afternoon, and evening. Now, what you notice is that the GFS is much quicker with the advancement of the front, whereas the European lingers the front farther back to the west. See them starting to separate here, the GFS more aggressive. That's very common. The GFS tends to move stuff fast. And at that point, a lot of scattered storms in both models over the southeast. But look at the difference here. As we go from Monday evening into Tuesday morning, afternoon, and evening, the GFS already brings the front through. The European has it lingering. Okay, so that's a difference in timing and probably total precipitation amount. Now, after that, as we work our way then into early next week, the GFS keeps trying to bring precip through those dry areas, and the European is not showing up with that. It's leaving this lingering front with higher pressure behind it. So as we play forward, when does the European try to do that? Well, not until Thursday, and it's pretty far to the south. And interestingly enough, the GFS tries to kick something off there too by the time we get out to next Thursday. But then let's just play this on forward, because it is important to note that as we get into, this is all the way out to next Friday, the models are attempting to keep this area active. And I want to show you why they're doing that, and then we'll discuss the likelihood of this. So let's go take a look at what we at least get through the next week by comparing the models. This is the week 1 European 12Z run, and what's shown here in these colors is drier than normal in these shades, and in the greens and blues wetter than normal. So you notice how the GFS in through here, there are pockets that it is not delivering the rain. Same thing with the Canadian prairie. But there are pockets in the eastern core belt and the southeast that are quite wet. From there, this is what the GFS says. And as we stated, this area was much wetter in the GFS than it was in the European model. Still dry here and in through here, and also down into Texas. So what we're now going to do is compare the models as we have been. And I know it's the same color bar, but let's make sure we know what we're talking about. These colors down here are where the GFS is wetter. That's the yellows to reds. And the greens to kind of the teal or blue is where the European is wetter. So the main take-home point, and if you're watching this before the market opens tonight, this is an area where the GFS is substantially wetter than the European. And to be honest, that is over the area that I think a lot of folks are most concerned about at this point, given the soil moisture issues there. So I'll just let this map sit here if you want to pause it and take a closer look. Because now as we move into week 2, the models do actually have some agreement there. And this has been a consistent story throughout this week. Let me show you what's going on. GFS 12Z on the left, European 12Z on the right. As we play forward, we've already talked about this week. This is the broader trough in both models that sinks through, and this is also going to bring in some cooler weather early next week. What ends up happening, though, over the Pacific is we get into a bit of a blocked flow situation. You see there's a broader trough here, pulls into a ridge there, and there is a low to the south of it. So we do end up getting high over low. Now, why we call it blocked is because the upper level flow will tend to have a motion something like that. So it's more north-south than west to east. And there's a reflection of this trough here. See it? So downstream, there's another one in position there. And the GFS says the same thing. As we go out here, this is next Wednesday, getting into next Thursday and Friday. This is the most dominant factor in the flow, pushing the ridge here into British Columbia. This does mean cooler weather possibly for California, But with both models trying to toss in troughs in through here, it will try to keep things wetter than normal in the midsection of the country. But the GFS will be much wetter than the European out into week 2, especially in the midsection because of the depth of the trough it's got forecast there. So to show you that, I just want to make one point, okay? One thing that has not stopped this year is we've not stopped transport of Gulf moisture. So as I play this forward, this is going through Friday into Saturday. So there you go. You can see the tropical system. You can see the moisture that's on the boundary. And then early next week, the low comes through on Sunday here. This is what possibly kicks off the storms again. And then after that, we do get a clearing. Look at that. That's a lot drier air that's forecast to come in. But we've not seen a complete drying out of the atmosphere. See how it opens back up as you get into next Thursday, Friday, Saturday. And if it just keeps opening up like this, there is moisture there to be rained out. And that's why the European model, when we look out exclusively to week 2, has this whole region. I mean, it's a large area here with normal to above normal precipitation. Again, why? Ridge here, broader trough over the east. So there'll be a lingering frontal boundary in there with open Gulf moisture. It'll rain. But don't look at this map and forget the fact that it is a smoothed map. It's not going to show you the convection. There will be folks that get the rain and folks that do not get the rain. From here, this is the GFS. And as I stated, it is much wetter in this area because of the depth of that trough than the European. And it's interestingly enough dry here, although we expect daily convective events down over the Gulf Coast. So that's all the way out to week 2. Temperatures now, let's blow this up so we can see a little bit better here. Extremely hot today, we talked about this. And as we go from there into Friday, that's a scorcher right in through this area. The west is extremely hot as well as the ridge settles in there. But as I get into the weekend, cooler here as the tropical system moves through, extremely hot in the west. But watch from Sunday into Monday and Tuesday. Big cool down coming in through this area as a result of that trough developing. Now the high over low pattern out west puts the heat into British Columbia, into the Columbia Basin. But the trough that's to the south tries to keep this area a little bit cooler. Yeah, I know it's still mid-90s, but that's cool for the Central Valley of California this time of year. So as we look out there, get that resized for you. As we look out there, the next 5 days, this is what the 12Z European model is seeing. And then this would be what we've got day 5 through 10. And the 12Z Euro did back off on the extent of the cooler weather in this area. And it pushes that ridge into British Columbia, as you can see here in the temperature field, which is kind of a reflection of that. Now, I know we're going on a long video here, but there's a lot to talk about. If you'll give me a few more minutes, I'd like to discuss the long range, because I also wanted to wait until I got the afternoon long range run from the European model. So this is the European Weeklies. Now, as we talked about in our last video, the previous run, can I show it to you here real quick? Let's go back. It was much wetter farther to the west than the new run. So let's go look at the new run. And the reason for the dryness that you see in this area and the wetter conditions here, we should just spend a moment talking about. Now, a lot of this is from the open Gulf of Mexico moisture transport. If you shove that much moisture that far north in the model, to be hydrostatically balanced, it's got to produce the precipitation. But it is robbing this particular area of its moisture. And when we start to look at the consistency among models, I would like to now show you the week 3 and week 4 forecasts from the CFSV2. Now you do notice that it does have a corridor in through here through the beginning of July that's showing up wetter. Now this model statistically bounces around a lot run to run. But then it does bring in, as we get into middle July, greater risk of drier conditions here, which we just saw in the European model as well. Wetter here, okay? So there are some consistencies in our longer range models. What I will be watching, this is most critical for pollination, all right, are these two things. It is the atmospheric momentum. If we start to see the momentum really falling out between 30 degrees north and 60 degrees north, in other words, if you start to see these colors showing up in this area, that would suggest that there's more meridional, more north-south flow in the jet stream, kind of like what we're seeing south of Alaska right now with that EPO signal. Now, if that continues and we rob the momentum here, that is something that can send, it just ruins the flow, and you run out of the energy needed to produce these weather systems. That's key number one. The second thing is going to be the MJO. Now, the MJO is a bit more tricky to diagnose and understand. It has certain phases that are great for rainfall across some of where we have our driest weather right now, and it also has phases that are not. What I do notice is that, I know it's an ugly graphic here, but the majority of the forecast is trying to keep the MJO somewhere in the Indian Ocean. Now, what I want to show you is what this looks like. Why don't we just come down here and look at this graphic? That might be the best. In general, historically, if there's subsidence in this area, it tends to favor drier conditions here. And we saw that in the longer range forecast. If we see a lot of rising motion right about in this area, that tends to be much wetter in this region. It's a connection, just a teleconnection. But if we have subsidence here and then subsidence over by Africa, that tends to point toward much drier conditions in this area. Excuse me. And rising motion in Africa, which we have right now, tends to increase the risk of dryness here. So I understand that I'm kind of opening a bit of a can of worms here by pointing this out over the next 15 days. But in my subsequent videos, the MJO combined with atmospheric momentum are going to be the key things to talk about. It's not necessarily going to be the ocean temperatures anymore. They've already done their job at setting up the atmosphere. So we're going to watch those, but it's going to be more about the near-term effect of the flow of the atmosphere that's going to be most critical. Hey, I appreciate you hanging on to the end of this one. A lot to cover today, but we'll wrap it up there. Thank you.